Algebra 1, set 114, functional notation. Okay, just to review, we talked yesterday about how to tell whether something's a function. So, is this a function? Yes, it is a function because there is a domain. The domain is the real numbers. And you can tell that it's the real numbers because the arrows keep going on. So you can see that x can be any number you want, and there will eventually be a place for it on the graph. And there's one and only one y for every x. Any point that I pick, there's exactly one y for every x. Okay, here's another review. Does x equals y squared describe a function? Well, let's see. Let's let x equal 4. So if x equals 4, what is y? Y can be 2 because 2 times 2 equals 4. However, y can also be negative 2 because negative 2 times negative 2 is also equal to 4. So for one x, we actually have 2 y's. So in this case, no, this is not a function. Okay, now we will talk about the vertical line test. Basically, the vertical line test is a test that you can use to visually see if something's a function. And the rule says if every possible vertical line that can be drawn touches the graph at only one point, then the graph is a function. So essentially, if you draw a vertical line and it only touches once, it's a function. Okay. So let's do an example. If I draw a vertical line, it only touches one place. Let's draw another one. It only touches one place. Do some more vertical lines. They only touch one place. Therefore, yes, this is a function. Let's try another one. If we do a vertical line, is it only going to touch one point? Well, here it only touches one point. What about here? And here's where we run into a problem. If we do a vertical line test here, there are more than one y for that x. So no, it's not a function. And what about this problem? Is there only one y for every x? It looks for most of the graph that is the case. However, there's one place right here where you have a vertical line, and the vertical line overlaps at that point. So the whole part in red are points, tons and tons of points that do overlap. So this case, no, it is not a function. So, use the vertical line test to determine whether this is a function. Is it a function? And we can say, nope, it's not because a vertical line test fails. Okay, so now we're going to talk about functional notation. Functional notation is just another way to write y when we have y equals. So functional notation generally looks like this. It can be f of x, g of x, h of x, r of s, x, t of x, anything like that. So if we have the equation y equals 2x plus 4, we can rewrite it as f of x equals 2x plus 4. And basically what it's saying is that x is your input and then 2x plus 4 is your output. So let's do an example. We could also write g of x is 2x plus 4. We could also write h of x equals 2x plus 4. So functional notation always indicates the element of the domain that's paired with an image in the range. So like I was saying, x is your input, then your equation is going to be your output. Now let's do an example. F of x equals 2x plus 4, and our problem is to do f of 5. That means 5 is your input. We plug it into 2x plus 4 to get the output. So 2 times 5 plus 4 becomes 10 plus 4, which becomes 14. So the answer to f of 5 is 14. It's the same answer we would get if we had just said let x equal 5 and then solve it. 2 times 5 plus 4, y equals 14. It's the same thing. It's just the notation that's different. Okay, now it says if phi of x equals 3x plus 5 and your domain is the real numbers, find phi of negative 2. Phi phi is a Greek letter, so don't let it throw you off. It's just like saying f of x, which is just like saying y. So we're plugging in our input, which is -2. We'll plug that in for x. Phi of -2 is 3x. 3 times -2 plus 5. 3 times -2 is -6 plus 5. And -6 plus 5 is 1. Let's do another example. If g of x equals x squared plus 4 and the domain is the real numbers, find g of 4. 4 is our input, so 4 squared plus 4 becomes 16 plus 4, which is 20. G of 4 equals 20. Okay, given f of x is x plus 2, the domain is the reals, find f of 1/2. So f of 1/2, we just plug that in for x. We get 1/2 plus 2. 1/2 plus 2 is 2.5. And that's your answer. Now, given that f of x is x plus 2, your domain is the integers, find f of 1/2. So this is almost exactly like the problem above. The only difference is that your domain changes from real numbers to integers. So f of 1/2 equals 1/2 plus 2, which equals 2.5. But our solution is not an integer, which is a problem. So we can't use that. So if it's not an integer, we say f of 1/2 is the empty set or no solution.